Alright, moving on to the next section of our test here. This is number 6 on the second page. Based on the graph, write down the domain range. So the domain is the x values. How far to the right? How far to the left? Well, this graph goes left and right forever. So it's going to go all the way to negative infinity on the left and positive infinity on the right. Ta-da! Domain is done. Range, that's the possible y values. What's the lowest that this graph goes? Well, it goes down all the way to negative 4 here, and it doesn't go below that, even over at negative infinity. And so your y's just go down to negative 4, but it does go up forever. And so it's going to go up to infinity. 7, list the x-intercept, y-intercept, and the absolute max or min. Okay, these are points. You need to write down the x and the y coordinate that goes with each of them. So x-intercept is where it crosses this beautiful x-axis. It's got a point right there and a point right there. That's 2 points. You need 2 sets of coordinate points. And so that one on the left is the point negative 1, 0. The one on the right is the point 1, 0. And there you go. 2 points, because it's 2 points. When you're getting your y-intercept, where does it cross? You're trying to find out where it crosses that y-axis. It's the point there, actually at the bottom. And that is the point 0, negative 2. This graph goes up forever, so it doesn't have a max. You don't put anything. You just do like none, or like non-existent, whatever. There is no max. Point. Okay, min point is actually here at the bottom. We actually wrote it down already. It's the y-intercept, so you can just write that point down again, being the point 0, negative 2. Getting the average rate of change between 2 points, that is the rise over the run. So, if you go from 8 here, for your y down to negative 1, that is a change of negative 9. If you go from negative 4 here for your x to negative 1, that is a change of positive 3. So remember, it's rise over run. So a rise was negative 3, run was 3, reduce it down, you got negative 3. Ta-da! Moving on to the next page, what's the next 3 terms here? It's a pattern of adding 4 every time. So you're going to have 28, 32, and 36. All recursive formulae start with a sub n equals a sub n minus 1. At least the recursive formula for this class. Start with this. So every number is equal to the previous number. Well, what do you do with the previous number to get the next one? You add 4. So put add 4 on the end. And make sure you tell it where to start, which is 12. Okay? So the recursive ones are going to have at least 2 equations to get it going, to tell it where to start and what the pattern is. The explicit one, on the other hand, let's do f of n equals your common difference, which is 4, in front of n minus 1. And then you add your initial value, which is 12. And there you go for that. Next thing you have to do is find out your a sub 12. A sub 12 means the 12th term in the sequence. You take 12 and you put it where that n is in your formula, and then you calculate. So 4 times 12 minus 1, add 12 on the end. Well, 12 minus 1 is 11, so you have to do 4 times 11, and then add 12. Well, 4 times 11 is 44. Add 12 is going to give you the grand total of 56. Moving over to number 2, this has a pattern of multiplying by 3. Not negative 3, just 3. You notice all of them are negative, so you're not multiplying by a negative because it's not switching back and forth. So you're going to get negative 81. Hold on, I need to grab a calculator real quick because I don't have multiples of 3 memorized that high. So 243. And then you times it by 3 again. You'll get negative 729. Recursive formula again starts with a sub n equals a sub n minus 1 times 3, because that's the pattern. And make sure you tell it where to start. A sub 1 is negative 1. Okay, when you write your explicit formula, remember, this one's geometric. So make sure you do the geometric form, which has your initial value in front, and then what you multiply by every time to the n minus 1 power. So initial value, common ratio with the n to the minus 1 power. Now that you got that, you're going to plug in 10 in for the n right there and calculate. So you're going to get negative 1 times 3 to the 10 minus 1 power. Well, 10 minus 1 is 9, so you got 3 to the 9 power. 3 to the 9 power is kind of a big thing. Please use a calculator. Just because I wouldn't want you to have to multiply 9 threes together. But when you do that, you get a grand total of negative 1, 9, 6, 8, 3. So negative 1, 9, 6, 8, 3. Ta-da! Done. Moving on to 1 and 2. I don't particularly have this on my paper, but I'm going to have to just kind of make up some graphs real quick.